Hello everyone, my name is Gaurav Jain and I'm a PhD candidate from Columbia University working with the Computer-Enabled Abilities Lab. Today, I'll be presenting our work on leveraging street cameras to support precise outdoor navigation for blind pedestrians. Navigating outdoors is a major challenge for blind and low vision people. The reason it is extremely hard is because getting from point A to point B requires them to follow instructions to the destination, which they must do in an extremely cluttered and dynamic environment where they must avoid other people, prevent bumping into obstacles, safely cross street intersections, all while maintaining their sense of orientation to the destination. Without the ability to visually perceive this complex environment, navigation is honestly very scary and mentally draining for these people. Blind people currently rely on apps like Blind Square and Microsoft Soundscape that are specifically designed to assist them. These apps use GPS, similar to mainstream navigation apps like Google and Apple Maps, and they give users turn-by-turn directions, but blind folks still feel anxious while using these apps because GPS is simply not precise enough to support blind people's navigation. With tracking errors as high as 10 to 15 meters in urban areas, users often run into obstacles, take wrong turns into small alleyways rather than at the street intersection that might be a couple of blocks ahead, and face difficulty while finding entrances. Here you see the storefront is pretty wide, but the entrance is towards the right. 10 to 15 meters can be a lot for these people. Furthermore, they do not really get any help about these real-time aspects of navigation that, for example, crossing streets or understanding where these different obstacles might be moving around them. And these users end up relying on their mobility techniques or switching back and forth between different apps that might help with those aspects. And so we need an approach that can precisely track users while also sensing their immediate surroundings in real time. One promising solution that checks off these requirements are cameras. In particular, cameras that are already existing outdoors, that is, street cameras. Street cameras are increasingly being installed in downtown areas for security and traffic-related applications. And with advances in computer vision, they have the potential to precisely track users while also sense the environment in real time. But naturally, with tracking users in public areas might raise several privacy and security concerns. And so in this work, we explore this idea of repurposing street cameras for outdoor navigation by considering not only technical challenges, but also the socio-technical challenges. We answered three main research questions. First, we understand various stakeholders' privacy concerns with using street cameras for outdoor navigation, specifically around assistive technology applications. Second, we develop a prototype to understand, how might we design such systems. And then finally, we evaluate the extent to which an actual prototype can help users navigate effectively. Our aim with these research questions is to really understand whether it's worth the community's efforts to leverage street cameras for navigation assistance. To answer the first question, we conducted a total of 6 interviews with various stakeholders, including blind users, local residents, local business owners whose shops might be visible in those cameras, and community board member as a proxy for government who might help us access many of these cameras. When it comes to privacy concerns, some people were totally fine with it. But the people who weren't, they worried about misuse. Either the government or law enforcement agencies would misuse their identities or hand off that information to companies for marketing or just tracking people. And so any kind of street camera-based system needs to obscure identities right from the get-go. It is important that anonymization processes happen at the moment of capture within the camera. And what that means is that the system should be configured to only use, for example, bounding boxes rather than actual images, as you can see here. Another interesting insight was that privacy concern vanished if an existing street camera was being repurposed for accessibility rather than installing new cameras. These people felt that while these cameras are already out there doing whatever they are doing, why not use them to serve people directly rather than only serving government-defined purposes? And so in our design, we use an existing street camera testbed for prototyping. Now, with these socio-technical constraints and the user's needs in mind, we answer our second research question by designing a prototype system, which we call StreetNav. Its computer vision pipeline processes the street camera's video feed in real time to provide navigation feedback via an iOS app. Let me show you StreetNav in action. Blind pedestrians first initiate a connection request through the app, which prompts them to wave one hand above their head.
Connect button. Wave one hand above your head. Connected. You are in Southwest Sidewalk.
On the computer vision pipeline, this activates a gesture-based localization module, enabling the system to distinguish them from other pedestrians, and then begin tracking their precise location on the map. On the right, you see the map, and on the left, you see the blind pedestrian sort of waving their hand, and then we track their precise location onto this map. That's essentially a top-down view of the environment of the same street intersection. Users can then select a destination from nearby points of interest.
Bus, grocery store, bus, phone, parking spot, button.
On the right, you see this internal graph structure, which we use to compute the shortest path to the destination. Upon selecting a destination, the app first provides an overview of the turn-by-turn directions, and then announces each instruction based on the user's position.
Start navigation, button. Walk 10 feet. You have reached sidewalk corner. Now turn right and cross the street and walk 51 feet.
After the user reaches an intersection, StreetNav helps them safely cross street intersections.
Please wait. Signal will change in 10 seconds.
Notice how it knows how the pedestrian signal is still blinking, and it's not enough time for them to cross right now, asking the user to wait until it is safe for them to cross.
You can cross now. 36 seconds remaining.
StreetNav identifies the signal state and computes the time remaining from the camera's view of the pedestrian signals, and also checks whether there are any vehicles that are still passing through the crosswalk. On the top right, you see the pedestrian signal. And then on the bottom, you see the vehicle that's still passing.
You can cross now.
And then the system announces that it's safe for them to cross. To help users gain awareness of their surroundings, StreetNav also notifies the users of any objects that might be in their vicinity. For example, trash cans or even other people that might be walking around.
Caution, person 3 feet behind.
And finally, it announces their arrival at the destination.
You have reached the destination.
Our paper includes the implementation details behind these functionalities. Feel free to check them out. I will not be going over these details in the talk today. Now, we deployed the StreetNav's prototype at this intersection in Manhattan, New York City, right next to the Columbia campus. And we used this to address our third research question. That is, evaluating the extent to which the prototype can actually support users' navigation. Our hypothesis is that street cameras can provide more precise navigation. And to test this, we first conducted a technical evaluation aimed at comparing StreetNav's tracking performance with that of GPS. GPS tracking has errors, as we know from prior literature, around 10 to 15 meters in urban areas, whereas with StreetNav, we found that there was a cumulative error of about 1 meters. However, we also found that street cameras are not as reliable as GPS, with occlusions, lighting conditions, and the user's distance from the camera itself impacting the robustness of this approach. More details on this can be found in our paper. Now, to understand how these errors actually affect users' navigation experiences, we conducted a user evaluation with 8 blind participants who tried both Blind Square, which is a GPS-based navigation system, and the street camera-based system StreetNav at a street intersection, completing several routes as part of this study. Let me show you some key findings that we derived by plotting the actual paths that these participants took, traveling with both of these systems. Here, I show the paths traveled by 3 participants. On the left, you see Blind Square, and then on the right, you see StreetNav. Here, I'm only showing 3 participants just for the sake of brevity and clarity. And you'll also notice that these routes are sort of mirrored with each other, but to prevent any learning biases, but essentially these are the same routes. With Blind Square, participants started from here and then got confused about which direction they should be turning in. In fact, P8 completely went around the intersection to reach the destination. On average, across all participants, Blind Square guided them into this sort of this more general area of the destination and not really precisely guiding them to the destination. With StreetNav in comparison, participants navigated much more directly to the destination and much closer to the destination. As you can see, that radius is much smaller. More details on the study design and other results can be found in the paper. Now, coming back to this overarching question, can we repurpose street cameras for outdoor navigation? Our exploration yields some promising results, but I'd argue that this is just the beginning and we still have lots of open questions. There are still several technical challenges around the robustness of using cameras. For example, errors when recognizing the user's waving hand included several false negative due to occlusions, as you can see in the first image, and then several false positive when someone else on the street might be just talking on phone or hailing a taxi. And waving hands can also call for a lot of attention to these blind people if they're doing so more explicitly. And so future approaches may leverage multiple cameras that might be already installed there for more robustness, and then maybe explore even more implicit ways of recognizing users. For example, combining the IMU sensor that you might have in your phone and then mapping that with the user's gait in the actual camera footage so that the user doesn't really have to wave their hand to tell the system that they are the ones who need help. Another consideration is scaling this approach beyond a single street intersection. In our work, we only tried it at a single street intersection. But even for this single street intersection, we had to develop relationships with different stakeholders, including the New York City Department of Traffic. And I think a big recipe of success for these kinds of projects would be to understand what kind of partnerships do we need to make this happen beyond just this single street intersection. In this image, I show the locations of cameras in New York City that New York City Department of Traffic has installed. And there's another problem that this proposes, which is we must also investigate how two cameras that are not really overlapping in view might work. And one solution is to still have GPS as part of the solution, where we have a seamless handoff between GPS and street camera-based systems, and precision can only be guaranteed when these cameras are available, and still it automatically goes back to GPS when they're not available. And for scale, I think Project Sidewalk from UW leads the way in showing how this approach can be scaled for sidewalk accessibility, and going just beyond a single city, multiple cities, to even different countries. And so there's still a long way to go, but zooming out a little bit, I think a key takeaway from this work is that the idea of embedding accessibility within cities, rather than putting the accessibility, putting the responsibility of getting more accessible access on the blind folks to, for example, buy a customized hardware. How can cities offer accessibility as a public service? And even thinking about whether there are any other existing infrastructure beyond just cameras that we are ignoring and could be repurposed to improve people's quality of life. Thank you so much for listening, and I'm happy to answer any questions.
Thank Gaurav. So any questions from the audience?
Yes, great talk. Thank you so much. This is Nels Newman from UCL. I was wondering if you considered using like a visual positioning system, such as what is used in these AR navigation applications. I was wondering if you considered it and if you see any way that it could potentially be combined with the camera-based solution they proposed.
Right.
Yeah.
So we did not consider that approach. We only focused on how can we repurpose street cameras. And the problem with that, especially for accessibility use cases for blind people, is that you need to position your camera in the right direction. And then at the same time, blind people prefer not having something in their hands and something that's more hands-free. I think the way it can be integrated is a lot of the times when, cameras might not be everywhere, but you might need more precision and you can just quickly localize yourself more precisely at that moment and then still use GPS. So I think there's a lot of scope in just seamlessly handing off between these different approaches to ensure guarantees of precision.
Great, thank you.
Thank you.
Hi, Gaurav. Great talk. Yihao Peng from Carnegie Mellon. So I was kind of curious about the idea of diversity of the street intersection. So the idea is I think you touched a bit at the end about Project Sidewalk, but I guess there's different types of maybe transportation tools, vehicles, different types of the patterns of the crosswalks. But also I think maybe something more interesting or subtle is the driving behavior might be also different across different countries or places. So I was just curious, have you thought about this sort of idea of making generalized, or maybe we may just you need more data, sort of maybe train customized model or whatever things for.
Yeah, so I think in this work, if you wanted to install this at a different intersection, all you need is the street camera.
Right.
And so we use the satellite view imagery from
Yes.
Apple Maps in this case. And if you have a camera, you probably have the street view imagery as well.
Yeah, exactly.
And then in this case, we had a manual segmentation of the different street intersections and where the crosswalks are. But you could imagine there are already existing modules that can segment the sidewalk, this crosswalk, and then that would be one way of scaling beyond just like a single street intersection.
Right.
And then regarding like navigation behaviors and like driving behaviors, I think we definitely didn't look at those kinds of aspects. But the good thing with street cameras is that you can essentially observe the environment over a long period of time,
Right.
and then identify some of those behaviors, and then maybe point those out to the users if they're interested in it. But I think for blind folks, they generally just want like more raw information so
Yes,
that they
yes,
can
yes.
make more decisions by themselves.
Yeah, great. Thank you.
Thank you.